Good morning, everybody. Thanks for joining. Welcome to today's episode of my little private stream here of my personal challenge, where I want to solve something that is called a word puzzle. And we started this last week. And I want to quickly recap what we did there. I was joined by my colleague Kim Philpotts last week. And together we introduced the idea of a little project that I have in mind or had in mind. And so what is this about? The idea was that I looked at my son's homework some weeks ago. Meanwhile, it feels like months already. And he was trying to solve what is called a word puzzle. I'm going to show you one here, so you know what we're talking about. Like I said, I want to keep this short because we're gonna work on the details, and we started last week. So this is what I'm talking about. It's literally a grid of characters, more or less randomly characters, and you have to find words in there from a predefined list. Here they are. And so instead of searching for these manually, I thought, can't we use some artificial intelligence? Can't we use some Azure-based projects to let the computer solve that? So that's how it started. And last week, when Kim joined me, we introduced the concept. I walked through my little flow diagram here, where I showed what is involved. So the parts that we need, we need to take a picture of the incoming puzzle. We need to then upload that picture to the cloud. We want to store it somewhere. We need some logic in the cloud in Azure that will then process the picture, split the individual characters, search for the words, recognize the characters. So some custom vision service will be involved here. Once we have got the characters converted or the images converted into actual text, then we will want to have an algorithm that finds the words in this now ASCII-based set of characters and eventually return all of this back to the client. So you see, that's why I call it over-engineering my son's homework, because he's long done with that homework, and but eventually he'll be able to verify that he found all the words in there. So what we did last week was we introduced Kim's solving algorithm. So he was kind enough to code that on his way back from the States to Australia. While he was on board a plane, he explained all of that, how he worked on that. And we ended up walking through the code, and you can find all of this at the GitHub repository. There's the URL. So if you look there, by the way, you'll find what I just showed here. So it's all of this here. You will find the completed project there. However, what I'm doing here in this stream, I'm walking you through the creation process of the project, through all the individual steps, and also talk a bit about the decisions that I made and why I made them and what components I used. So I think that's a lot more interesting than just cloning the project and running it and saying, hey, it doesn't build. So no, I guess it will build. I just tried it. Even builds with the new Visual Studio 2019, so that's cool. But what we started last week, so stop rewinding. So what I want to do is I'm going to create this bit by bit. And what we did last week, we started with building the solver. And this is the solver. It's just a static class that we have here. And that static class takes as an input parameter, and I gotta look for it here. Here it has got a method that is called search for word, and search for word accepts a grid, a two-dimensional array of characters, and you can make it search for a specific word in there. So you would have a list of words and repetitively call this method, and it would tell you, yes, this word was found, or no, it cannot be found. But this requires us to have data available on an ASCII basis. If you want to learn more about the process of the algorithm, then go back to the previous episode of this stream. It is available on YouTube. It has a bit of a problem with the audio levels, so it's very unbalanced. I tried to fix this partially, so I hope today this is a lot better. The adjustments should be a lot better today. Right, so what are we gonna do today is, if I go back here to my overview, what we want to do today, and want to see how far we get. I want to get started with not acquiring the image because we're only going to upload it, but what I want to do is, once we have an image, we need to split that. We need to figure out what are the individual characters, and to do that I'm going to introduce a component which is the ImageSharp library from SixLabor. Really amazing library, already mentioned that last time. So that's what we're going to use today, and build a little method that helps us split the image. That's the first part. And then depending on how far we get, I guess we'll also have time to look at the uploading portion of the code, where we talk about blobs, how to get data into a blob storage. Last time we already set up the Azure blob emulator and the Azure storage explorer, so we can run all of this locally without going to the cloud, but we can also deploy the entire project to the cloud. So now let's jump into the code. And one of the first things that I want to do here is, when we created the project last time, we just ended up having an empty solution, and that empty solution contains one console-based application. It's this program here, and I can run this. This is our test program where we can see how the algorithm is looking at a relatively small word puzzle here, and it tries to find the words fun, fear, and off, and it does that successfully. So that's our test that we have here, and we want to use this later on, not only in a console app for testing, we also want to use this, of course, inside Azure then. So that means we have to put all of this into a library, and that's what I want to do now. Now let's see if the stream recovers. Something's going on. Let's see what is going on here. And is it back? So my live preview of the stream just showed me that it got disconnected, and now it seems to be back. Lucky me. Oh, so here I am again. That's better. Yep. So now the stream seems to be live again. Quick introduction, and if I... What is it doing? Now it's showing a different scene. So if you wonder why does it sound navigation on, now say a navigation on iOS, that's wrong. So let me try to switch this. It switched to a different scene set, one that I definitely not want. So let's go back to the right one. So this could take a bit. And so that's better. That's a lot better. Here we are again. I don't know what just happened. I think I can explain it. I've got two different setups here, one that is for our Xamarin University content and one that I use for my private setup. And somehow I managed to switch to the other set of scenes here in my streaming client, which is apparently a bad idea if you do it live. So now we're back, and what I wanted was really this here. So that's what I wanted to see here. Okay. Yep. So what I was saying is we need to use this code here, this one, also from within Azure. So I think one of the first things that we should create here is a library. And well, Since everything is .NET Core today and .NET Standard libraries, well, why don't we create a .NET Standard library? So let's just add this here, and then want to move the code in there. I'm going to add a new project, and I'm using the new Visual Studio 2019 here, and I'm going to give the search a try. So let me see if we can find this. You see, they completely refactored the user interface, where we had this kind of overwhelming wizard-like dialogue with a lot of selections. They now have got something that is search-based, and that should make it very easy to find what we need. And we need a .NET Standard class library using C#. That looks good. Now let's go for next. And the name of this will be Puzzle Solver lib, and we want to store this in my on the source, so that's good. Let's create that. Here we are. Welcome, Yeti Man. Thanks for joining. Question: what is .NET on the chat window? .NET is the framework provided by Microsoft. It's the framework that supports languages like C#, like F#, and Visual Basic that you can use to write your programs in. And meanwhile, it's open source, it's cross-platform, and we use this to implement our logic here today. So without adding anything, I'm just going to take my solver here and move that into the library. So that goes in there. And we're going to delete this class. I don't think we need this. There's just an empty one. So we have this in there. And that means we can remove it from here. Let's delete this. We moved it into the library. And let me check what our namespaces are. We should adjust these to Puzzle Solver library to match the library's namespace. There we go. And then we could change our test application here. And I'm gonna create some folders here. I'm a big fan of solution folders in Visual Studio. I'm gonna go ahead and add a new solution folder to organize things a bit, and we're gonna call that test or test apps maybe. And I'm gonna move the Puzzle Solver test in there. So we're going to end up having multiple of these test projects in the end. There is going to be one that tests the puzzle solving. There's going to be one that tests the image splitting that we're going to work on today. There's another one that tests the uploads and so on. That's this one. And now we have to fix this. This will no longer work. It's going to complain here saying it has no idea what this solver is. So let's see if Visual Studio can figure this out for us. Yep, and here it already suggests to add a reference to the newly created Puzzle Solver library. We're going to do that. And then this one is happy again. So that means now we've got a dependency here on that Puzzle Solver library. Good. Let's see if this still builds here. It's just step number 1. All right, so this is still working. That's good. Let's stop debugging here. So now we're getting a bit more organized in here. And the next thing that we now need is, well, something that would allow us to split the image to work on that. And this is also going to be part of this Puzzle Solver library. So I'm going to go ahead and add a new class in here. And we're going to do, just like with the solver, we're going to do one more static class that is going to have just one method that allows us to split an image. So why don't we call this our image processing? And that's going to be a class. Let's add that. We add it in here, Puzzle Solver library. That's good. So what do we need in here? Well, the idea is, and I should probably switch over to an example image, the one that I had there before. So let me open this in a new tab. So that's my example image that I have here. If we look at this, I can probably zoom out a bit here. If you look at this, this is one big image, and let's download that. Let's save that image. And we wanna save this as our, I'm gonna save it right into the solution, develop. So there's this source, and there's the, we're gonna need this in a test application. I'm gonna put it here for a second. I'm gonna put it there, and I wanna call this our test puzzle, test puzzle.png. Good, there we go. So we have this saved. And if we look at this image, we find that it's starting up here, right where the cursor is. It's not that it starts right there, it's starting there. So what we need is, we need to process that image, but we can't say, well, take the image and then split it equally in cells with a width of 40 and a height of 30 or something like that. So we need certain things as parameters for our image splitting method in order to extract the individual sub-image that represents our characters. So let me see if I can add this here. So here, that would be our entire image, if I highlight that quickly. And within that image, we need to, oops, don't take a screenshot. We need to make sure that we find the vertical offset where the actual grid with the characters begins. We also have got a horizontal offset here. So this corner is what we need to define somehow. So when we split the image, these are already two parameters. Where in the image does the actual grid start? That is some X and Y offset that we're going to need here. Then our cells, they have got a certain width and height. And this width and height is, yeah, it should be equal. It's not perfectly equal for this specific image, but that's what we're looking for. So this would be the same everywhere. Every cell has got a specific width and a height. So width and height is something that we will have to define. And then we also need to talk about spacing, because if we just have width and height, if you look at this image closely, you find that it's, if you ignore the cyan borders here, the cyan rectangles for a moment, you see that there are separator lines, the gray ones. So we don't want those, because if we try to recognize a character later on and it would have this border around it, that could confuse the artificial intelligence. So we need the cell width and height, but we also need a spacing. And because that image is not always perfectly aligned, it may be a bit distorted, we need a vertical spacing and we need a horizontal spacing. And the result will be that we capture more or less perfectly each and every character. And this is what I try to highlight here with these cyan rectangles. So you see the characters, they are not always perfectly centered within these rectangles, but using the parameters that I just talked about, I can make sure that every character is really within that rectangle. So the D is slightly to the bottom right, whereas the A here, that would be, yeah, almost perfectly centered. So that's important. This is also the tricky part. We will have to play with these parameters. So that's what our method needs. The image as an input, the X and Y offset where the grid begins, the width and height of the cells, the vertical spacing between the cells, the horizontal spacing between the cells. And of course, it will need the amount of cells. So the rows and columns that we have. All of these are parameters that are going to go into our image splitting method. So I'm going to just start adding this here. We're going to have a static class, like I said. Let's go over here. It's going to be a public static class image processing. And in there, we want to have a helper method that helps us split an image. So let's think about that. That would be public static. And I don't know yet what that is going to return. So let's make it void for now. And I probably want to zoom in a bit more for you guys. Maybe like that. And we're going to call it split image. And it's going to contain some code. So let's talk about the input parameters that we just mentioned. It's going to have a certain number of columns that we have there in that grid. There will be a number of rows, obviously. We said we would need an offset from the left-hand side. So let's call that offset left. We will have an offset from the top. So this is where the grid begins relative to the y coordinate, that is 0. If we say 0 is at the very top, we will need a horizontal spacing and a vertical spacing. And what was the other thing? We said we would need a cell width and a cell height, also assuming that not every image that we're going to process has got cells where the width and the height are square values, but they are just rectangles where a cell could be higher than it is wide. So that's the parameters. But how do we now process that image? So I wanted to add that. We're going to need a little another test program here so we can try out our split image, which we're about to implement. So we have the puzzle solver test in here, and I'm going to add a new project in here, which would be a .NET Core console app. Yep, that's one here. I'm just looking at what is the difference here. So I installed Visual Studio 2019 just yesterday. I haven't used it too much, and I'm not even sure if everything that I'm trying to do today will work, but that's the challenge of the live stream, right? So what is the difference between a console app, .NET Core? That's .NET Framework, right? So we don't want that. And that's Visual Basic. No, we want that. C#. And you see, this is going to work on Mac OS. It's going to run on Windows. That's great. That's exactly what we want. So this will be our image splitter test. Let's create that. Now I know that we could potentially also create real testing projects and unit testing projects, but what I'm doing here are not really unit tests. So I decided to go with a console application because I'm processing images, I'm saving data, I have to compare, I have to look at the generated images that will be saved to disk. So I decided to go with a console app instead of with a unit test here. And again, this one needs, it already has the, no, that's not it. It are gonna need a dependency here. We're looking for our projects. We're gonna add our library here, okay. And into that image splitter test, I'm gonna make that our startup project here. We are now going to add the test image that I downloaded previously. So let me see, where did that go? Here it is, our test puzzle. And we want to move that here into the image splitter test. There we go. And I will want to make this here an embedded resource. So if I open up the properties, I could load this from disk just like a regular file, but I want to embed it into the project here for testing. So let's change the build action here to be an embedded resource, and we can always copy that. That doesn't really matter what we set here. And that now makes this test puzzle.png available here within this image splitter test application. Good. But now back to our image processing library. We haven't done anything with the image yet. So how would we do that? Well, as of, I don't know when they converted it, but the system.drawing namespace is completely available cross-platform. So using system.drawing would be one way of processing our image, of loading it. But I found something that is better, and this is a recommendation that I found was made by Scott Hanselman in one of his blog posts. If you haven't checked out hanselman.com, if you're interested in .NET, that's the place to go. So he said, yeah, system drawing is available, but really the library that I'm about to show you is amazing. So, and I checked this out, and it's called ImageSharp. You find that at SixLabors.com. It's an open source .NET graphics processing library, and it really does anything you can imagine. And it's such a joy to use the APIs that are in there. They are a bit lacking on the documentation side of things, but you really don't need a lot of documentation. You find some code samples, and if you look at one code sample and see how that works, and you know what you're planning to do, you can easily figure out how to use that library. So it's a super well-defined API that is used here, and we want to use that library. And that means we're going to install the package, the SixLabors.ImageSharp. I'm going to go back here. I'm going to add this here to the Puzzle Solver library. Manage our NuGet packages here. And we are looking for SixLabors.ImageSharp. And when I tried this first, this was all in pre-release, so that's why I still have this checked here. Let's see. Now it still is. So you see, make sure that you have got the include pre-release set here. Otherwise, we would not find this package. And we will need this one here. And we could also include the drawing one. Let's install both. So this one here is just for processing, like loading a PNG image and saving it away as a bitmap. I was so tempted to say as a GIF now, but then I was contemplating whether it's GIF or GIF, so I tried to avoid that. Or you could resize an image, so that's what you can do with this one. And the drawing is where you can overlay graphics. So these cyan colored rectangles that you saw in the image, that's where I use the drawing functionality. So let's install this one here. I'm gonna add this to the library. I see there's a couple of dependencies that will be added here. And yeah, let's add the drawing too. I mean, it doesn't hurt. Maybe we also wanna draw these rectangles. Then we would need that. Okay, so they have been installed. It's always nice how easy it is to add functionality by using NuGet. And now let's go ahead and start adding this. So this should now show up as SixLabors.ImageSharp. So we certainly want to use that. We then need, well, I guess that's it for now. Everything else should then be proposed by IntelliSense. So how are we going to handle that? Well, let's think about how do we want to load an image. We could load an image from disk. We could load an image from a blob. We could load an image from a URL. We don't know yet. So let's think of a way to load an image from something that would always work. And that something is just a stream. So if we manage to provide our images as a stream, then we can just make the caller responsible for providing that stream. Whether the caller then loads it from a blob or from wherever, it doesn't matter. Let me quickly get rid of this blinking timer up here. So can we stop that here? There we go. So let's say we want to have a stream in here. I'm gonna get that stream in there. It's just a stream, whatever. That would then mean it could be a memory stream, it could be a file stream, whatever you have. So that's our image stream that we have there. Let's resolve that. It's using system.io, and we're good to go. And now you want to load an image, and you know that there's the image type in SixLabors, or maybe you don't even know that. You just go SixLabors.ImageSharp, and you think you want to process an image. So what would you be looking for? Well, it's probably called image or image something. So I just thought, let's use image, and then you type dot and you go through the methods and you find, well, who would have thought that? There's a load method. And then you go for the parameters, and thanks to auto-completion here, you see there's a load method that accepts a stream, an array of byte, a path, a span. There's everything you can imagine. And already when trying to load my very first image, I was convinced that this library is exactly what I was looking for, because it accepts any data type. It supports kind of all image formats that you can imagine. So I went with this. So let's load that, and we want to load this image, well, of course, from our image stream. That's what we're going to do here. And everything that I do with this ImageSharp library implements iDisposable, which means we could just wrap a using around that and not waste any resources, support the garbage collector, say, hey, when we're done, let's dispose that. You don't have to worry about that later. We're taking care of it. So this is our image. Let's call that our image. We can just load that there. And then we could say, well, what if I want to draw these, rectangles that we just saw, like the cyan ones? What if I want to highlight the image and overlay this in order to verify that the parameters that I'm using were correct? And I could now draw on the original image, but if I also want to split the original image, I would have a problem, because then the sub-images that I'm splitting out of the original image, they maybe contain what I draw on top of the image. So to avoid that, I want to have a copy of that image in memory. And again, super simple to do that, just another using. And we call this our cell highlight image, or just img, which is image.clone. There we go. So like I said, this is all, in my opinion, super intuitive. If you have used an application like Photoshop or Pixelmator, you're looking for an operation, and we'll see this in a bit. You want to crop an image, well, it's probably called crop, and that's exactly what it is here with ImageSharp. So now with our clone in the memory, we want to start splitting the image. So let's go back here, look at our image. So there it is. How many sub-images do we need? Well, it's number of columns times number of rows. So we have here 2, 4, 6, 8, 10, 12, 14. That's 14 by 14. What is that? That's 196 sub-images that we're going to generate here. So there's, of course, different ways of iterating over that. I'm just going to use 2 for loops here, and we're going to do this for every row, column by column. So the first image that we want to save is this one here, then this, then that, and then go back and process the next row. So I'm going to have a current row here. That's going to be 0, and the current row is going to be lower than the rows parameter, current row plus plus. And then we're going to do this all over again for our columns. Current column, that would be number of columns plus plus, like that. So that's all the sub images that we need. Now every sub image or every cell now has got a specific X and Y coordinate which we have to calculate. And if we again look at our image, that would be the top offset of the image plus the left offset of the image plus the width of the cell times the column number plus the distance between the cells. So we have to take everything into account. So let's create a variable here that would be offset X would be offset left plus the current column that we're working at multiplied by the width of each cell plus the horizontal spacing. So that's our effective X coordinate. And then we're going to have an analogy to that, and Y coordinate. So that's offset top. And that's not current col, but current row using the cell height plus our vertical spacing in there. And with this, we could now crop the image, but also draw our rectangles around it. Let's first go ahead and, what should we do first? Draw the rectangle or crop it? I think we start with drawing the rectangle just to see that what we're doing is correct and maybe have a look at the result and then extract the sub images. So let's draw something on top of that. To draw, we said we want to use the cloned image. So that's our cell highlight image. And now this was a bit tricky. It took me a bit to figure that out because originally I was looking for a method like draw or rectangle, but that does not exist. So the way that ImageSharp is handling this is via a mutate method. And that mutate method, to make it a bit more difficult, is in a different namespace. So we got to add a using SixLabor's ImageSharp processing here. And it takes a delegate that is a context. It's a graphic context. And now with this, we can start drawing. And there you find everything. There's draw, draw image, draw lines, draw polygon. And although I was hoping for a draw rectangle, that is not there. I was eventually smart enough to figure out that, hey, a rectangle is a polygon, so I should be able to get away with that. So let's do that. We want to draw a polygon here. Just want to make sure that I got all the parentheses right. And the polygon now takes various parameters. The first one that we need here, I'm gonna highlight that again. So the first one that we need is a color. Then it wants the thickness of the path that we're about to draw, and then all the individual coordinates. And I think they will be in clockwise order. Not that it would matter. I think you can specify the coordinates in any order as long as it makes sense. So it should be clockwise or counterclockwise, but not top left and bottom right. So let's draw that polygon. We need a color, and again, this is something that was not super easy to discover. So there's this RGBA class or definition in there, and again, you have to resolve that. So it's in a different namespace, so you got to use the ImageSharp.pixel formats there. So that's when it's going to show up. But in there, we then have the predefined colors. So I said we want to use the cyan to highlight that. So that's this. Then we need the thickness of the brush that we want to use. And then let's define the points. And the points that we have here, they are type, no, not of entry point, not found exception, certainly not. What we want is a point F here. That's in SixLabor.primitives. You see, this is the same type that we also find in the drawing namespace, but here it's in the primitives. So our first coordinate would be at the X and Y coordinate. Then let's copy that. And if we go clockwise now, if I go back to the image, so that would now be top left here. The next is then this X coordinate plus cell width and the Y coordinate. So that's cell width plus Y coordinate. But since this is, we gotta be careful here, because let me think about that. So the width, let's say the width is 1, and we have got a drawing width of 1 of the brush. So we want to maybe remove 1 here to get a bit back and have the right coordinate. Or would it be +1? Well, let me think about that. We've got, let's say this is going from 0 and has got a width of 10. So that would go from, the pixel would be at 0 and the other one would be at 9. Yeah, so we always have to subtract that 1 here. It's width minus 1. That's the coordinate that we're interested in here, because what you specify here is not the width of the rectangle. We're drawing a polygon. That's all coordinates. So we have to subtract 1 here. Yep, so that looks right. Then the next one, that would be, I'll make it rid of this here. That would be cell width minus 1 for the X coordinate. And that would be the bottom right one now. So that is Y plus cell height minus 1, and then we have got the X coordinate And we have got y plus cell height -1. Is that correct? So that would be bottom left. And that would be 4 coordinates. That's all it needs. Okay, so I want to put this on a separate line too, so it's clear what this is. Sign color around this. Okay, so right now we have changed this image, but just in memory. So we could say this is for verification, debugging, draw a border around cells. This is really useful because we'll see that getting these values here right can be tricky. Depending on the image that we're using, it takes a bit to play around to get the correct widths and heights until you really capture all of the cells. If we are maybe towards the end of this series, if we are writing a client that is, let's say, running on iOS or Android, we could have something where the users could just adjust that grid on the screen, kind of like an overlay on the image that they want to upload. But right now we don't have that. We're all doing programmatically from the command line. So we gotta go with that. That means we have now mutated that image, and that means we have to save it somewhere. And we can do that by going outside of our for loop here. So that's this one. And let's save the cell highlight image. And we can save this as, you can see, we can save this as bitmap, as GIF, as I just learned. I'm still saying GIF, forgive me. As JPEG, as PNG. And I think we should save that out as PNG again, then it's lossless. And again, we could save that as a stream. You see, get it in as a stream, save it out as a stream. So let's go ahead and do that. And maybe we want to return that stream. So if we're working with streams, it would be kind of unwise now to say we accept a stream as an input, but then when we return it, we give you a location on disk where it's stored. So we should probably return that as a stream. So let's create that here. Let's say we've got a new memory stream. Cell highlight stream is a new memory stream. This is where we want to save this to. I'm going to save as PNG to this cell highlight stream, like that. So once it's saved, we also want to make sure to return everything back. So let me just, it's a bit hard to see everything here. Maybe I can get rid of this to get a bit more space. Oh, that's better. So let me check, where are we? We are inside that using, that's good. So this has been saved here. Now we want to make sure to return that, of course. So let's create that here. I'm going to move this outside of the using and make that method return a stream, right? So we can return that memory stream back here from the method. Return cell highlight stream, like this. So there's one thing about streams that is, by now I know it because it happened to me so often. When you're creating like a memory stream in here and you're saving something, then the memory stream's position is no longer 0. So we have saved that PNG. So the stream has moved from, I don't know, 0 to a number of bytes that we have written. And now if we return that stream, it's actually at that last position. So if our caller now wanted to save that memory stream to disk, nothing's going to happen. And it took me a while to debug this the last time it happened. So what I want to do here is I'm going to rewind that stream. I'm going to set its position back to 0 before we return it. And then let's get that back. So that's the code that we need to highlight the cells. So we give this a try here before we then use if the coordinates are right, we're going to use a similar logic to then actually split the image. So let's go back here to our image splitter test program. There it is. And in that image splitter test, we will want to, where is it? There it is. We don't want a hello world. We will want to load, first of all, our test puzzle.png. So that's what we will need to access. And of course, we will have to split that image. So maybe let's start with this. That's the easy part. Image, what did I call it? Image processing. Use puzzle solver lib. That's cool. Split image. Now we need an image stream. Well, let's just say we have one image stream. And then we have to, well, like I said, we will have to play a bit with the values here. And I want to name the parameters so we know what this is. Columns is obvious. Columns in my example, I remember that that's 14. Then we have got the number of rows. That's also 14 for that specific puzzle. Then we have got the offset left. And well, for the offset left, here's how you would figure that out. You go in here and we have saved that image, right? So let's open this up. This file comes from an untrusted source. Well, I don't think so. That's fine. So here's how you would find that out. You would just look at that image and well, look at the coordinates. You can find them down here. There they are. No, not there. Where are they? There. They come in 891, 876, and just try to find out what is this corner. So that's approximately 36, 110, 35, 109, something along these lines. If we want to be well within this rectangle here, it's closer to 40, 112. So if we go with 4114, 4115, something along these lines, it should work. So let's go and try that. So offset left, that's 40. Offset top, that would be 115. Then we have got a horizontal spacing. Well, the horizontal spacing, this is something that you just have to guess. The problem is if you make the horizontal spacing too big, then eventually it's gonna overlap the separator lines. If you make it too small, you may truncate the characters. And it's just a value to try. We can go with 10. And we have got a vertical spacing. And because we have no reason to assume that the image is very distorted, let's go with a 10 here too. And we need a cell width. And again, this is really just about, no, not that here. Where did I open that in Visual Studio? Can we please go back to it? Where's my test puzzle? There it is. If we highlight this, it says 45 by 47. If we use the actual character size, it's closer to 30 by 30. Again, this is something that we have to try. We could say the cell width is maybe, let's meet in the middle. Cell height 34 and 35, let's make that 35 too, like that. So that's how we would split that image. And what we get back is, well, a highlighted image where we can see the rectangles on it. It's a highlighted image stream actually, and we want to save that stream out, or yeah, I reckon we're just gonna save it to disk so we can see it there. Now our stream will be saved to disk, so we're gonna need a file here. We're gonna create a file dot creates a file. Or what's the thing with create? There was an open. open a file, open write. Open write is cool. So create will make me specify what I want to do with that file, whereas open write is going to do that directly. So it's going to open it. If it's not there, it's going to create it for overwriting it. So we want to save that to a path here. So let's say that's our highlighted dot. So we said this is going to be a PNG. And that will return us a file stream that we can save to. And with that file stream, we can use a copy to. We could use a copy to async, but really no need to do that here. So I want to copy our, no, the other way around. We want to copy our image stream, right? The highlighted image stream, that's what's supposed to be copied into that file stream. Mixing up source and destination here. And when we're done, then let's close that puppy. Let's close it. There we are. So the only thing left is this one here. Now, had I saved the image to disk, I could just use another file open read to get this into memory, but I put it here as an embedded resource, make it part of the solution. That doesn't really make it more complicated, but I picked that approach because I always find that interesting. How can we get a binary resource out of the solution? So if you remember, we marked this one here as an embedded resource. I saw this first time during a class in one of our Xamarin Forms courses, or in our Xamarin University courses. I think it was an application that used Simpson characters or something. That's where I stumbled over that. It's like, hey, that's kind of nice that you could include these binaries into a library and load these images. So that's exactly what we're doing here. So the trick is to get to the current assembly first, and you can do this by using assembly, which you have to resolve using system.reflection. Get executing assembly, that's what we need here. So this takes us to the current application, and then we can get a resource name out of that. So with the assembly, we can get a manifest resource. So that's manifest resource. Oh, you see, I could get a stream right out of that. Manifest resource streams, that returns a stream, that returns a name. Yeah, we could do this bit by bit. Let's get the name and then we go to the stream. And now this returns all the resources in there. Now I only want a specific one. Now in my case, there aren't too many, but oh no, it's complaining because I said it's a string there. Yeah, so it expects a string array. So what we want here is we only want one of them, and we could just use link to filter that. So let's use this here. We say we want the single one where the name or whatever is equal to, or better, ends with, because we'll find that this resource name is not just the name of the file, it is prefixed with the entire assembly name. So that would be image splitter test.testpuzzle.png. So if we only compared for testpuzzle.png, it would not work. So here we go with testpuzzle.png, like that. So this is giving us the resource name. And now what we need is an image stream. So finally we're getting there. We can now use the assembly dot get manifest resource stream using our resource name here. So again, taking the file name, we get a resource name, which is the complete thing prefixed with the assembly name and everything. And from that we can get a stream. So that was quite a bit of code, and let's just see if it builds. So let's rebuild our puzzle solver library here. And if I look at the clock, I can tell by now that we're not going to make it to the blobs today, it's just gonna be the image splitting part, because we haven't even started that. So I didn't believe it when we were chatting with other Twitchers. It's like, you're never gonna make everything that you planned. So let me run this. .NET.exe is running. And exited with code 0. That's good. Let's close that. I want to see what it did. Let me just open that here, open containing folder. And we should find that under bin debug netcore app. And indeed, there's a highlighted .png file in here. Now let's see what's in there. And well, there it is. Yeah, okay, stupid me. Because I took the image as an input that was already highlighted, it's pretty hard for us to see what it did, but I can tell that it's completely off. So our parameters are just wrong. So let me fix that. Let me try to see if I can get the original image, the one that is not highlighted. I should have that somewhere here. So let me find that. Open. I'm gonna need this here, and it's there. Oh, it's a JPEG, but it doesn't really matter. So let's just make it a JPEG then. I'm gonna move this in here. We're gonna get rid of our test puzzle.png. So you see this one here is without the highlights. That's of course what we need. So let's change this here to be a JPEG file. I need to set the properties here again to make this an embedded resource. And let's try again. And it exited 1026, that's the one. So there we have it. And as you can see, those values that I picked, they were not quite right. So we're missing the last two columns here. That means either the distances did not match or the width of the cells did not match. Now, since I looked at that particular image before, I can probably guess what is wrong. So I think we should play a bit with the spacing here, space that a bit further out. And while we're at it, maybe also increase this one here a bit, make it a bit wider for every cell, and also stretch it a bit. So let's try again. We're getting there. We're getting there. So we still need more width and a different spacing. So you see, it's relatively small changes that I'm making here. It's really just 2 or 3 pixels, but since everything will be multiplied here by the number of rows or the number of columns, plus the spacing in between, that's always going to make a big difference at the end. You see, now we're almost there. Now that seems like that was a bit too far. So let's look at it again. The width, I'm gonna reduce this one here again. And what about the height? So as we move downwards, we could say we could maybe reduce the height a bit. It doesn't really matter if it's missing 1 row in the beginning, but in the end, multiplied by 14, we're quite off a bit. So let's try these values, and they look familiar to me. Going back here. You see why a client application would make sense, where you can simply overlay a grid. If you imagine you would have like on an iPad, you could load that image, you could maybe rotate it a bit, you could distort it, and then you would have ability to just use pinch and zoom to create a grid-like pattern, and you keep on rearranging that till it matches all the individual characters. But I think this is kind of good. So down here, yep, we did not catch the border. So that looks good. I'm happy with that. Yep. So let's go with that. So these are our values for that specific image. So we verified by overlaying these rectangles, but we haven't really split the image. So that's the part that is still missing. So let's do that. Luckily, this isn't really hard here. So here we are drawing the individual cells, and now we need to split into individual character images. That's what we have to do now. So how would we do that? Well, of course, we don't want to break the original image. As we see, we're going to use a function that is called crop that takes a piece or a section of an image, but the moment we crop the original image, it would be gone. So again, we need to find a way to avoid that. So that means we're going to create a cropped image here. And first of all, we start by cloning that. That's just all we do. And what is interesting, if you look at the clone method, there's different overrides. There's a plain clone like we used it to create the highlight image. There's one with the configuration, and there's one that takes an image processing action. And that's cool because this allows us to do the cloning and the cropping in one go. So we want to clone the subsection that we tell it to crop to. So let's take some input image here, or some context as it's called, and that input is now what we can crop. There we have it. And this now really allows us to use a rectangle finally. So what is our rectangle? Before we only had a polygon. We're creating a rectangle. That rectangle has got a well, X, a Y, and a width and a height. This time it's also really width and height that we have here. We have all the coordinates. So we have X and Y, we have cell width, and we have cell height. That's exactly the rectangle that we added on top of the image up here. That's this one here. Let's go ahead and do this. Add a bunch of parentheses, can't hurt, and a semicolon, and it seems to be happy. Okay, so we have now got our cropped image, and that cropped image again has to go somewhere. Now we're gonna use exactly the same method that we used down here. Let's save it out as a PNG, but again, the question, where are we gonna put it? So let's make another stream here. So we're gonna have is that now a cropped stream? Sounds kind of strange, but I guess it is. So let's make a new memory stream here. And we're gonna save our cropped image, save that as a PNG, and save it into the cropped stream. And again, as a service to our callers, let's just reset the position here back to 0 once it has been saved. But now the question, where are we going to put it? We already have a return value, which is a stream. And the solution that I use here is that, well, I just return an array of streams or a list of streams. So the first stream would be the image, or not the other way around. So the last stream would be the image with the overlay in case somebody needs that. And the others, those would be the individual characters. So let's turn that here into a different return value. Let's return a list here. And I'm going to create a list of streams here. It's going to be a new list of stream. This is where we want to add everything. So now let's add this streams.add cropped stream. So this is going to add, in our case, all the 14 by 14, 196 13 by 13, 169, 196 sub images, and then the last one that will be the cell highlighted stream here, this one. And then we want to return the streams. Nope, that one here. It should be happy. And that's pretty much all we need. So of course now this needs some adjustment here to our image splitter test, because it's going to complain here that this is, that's just now streams that are returned here. That's an array now. And we can save out every stream in the array just to verify that this is working. Now we could say for each image stream in streams, let's create a file stream. I'm going to open that, and well, I guess we need some counter here. Int counter equals 0, and then we could say every time we saved something, the counter is going to increase, so we can have sequential file names. We call this here subimage counter plus plus. We can save this here. So that's our file stream. That's where we copy our stream to. Image stream, copy to file stream, and close that. So this should now generate in total 197 files. Let's see. Let's run it. And it's done. You see, this is super fast. It's really takes no processing time. It's already done. Let's switch over here and see what it did. And indeed, we've got a lot of sub image. I'm just going to pick one of them. And it's an A. Let's try another one. 27, it's a P. So that looks good. And it should go all the way to 196. That should be the one where we put the overlay on. So just double checking, 95 is a T, and if we look at our original image, where is it? Test puzzle, that's a T, so that's good. So I did it in the right order, line by line. We've got all of our images now stored. Okay, so with that in place, we have got another puzzle piece solved. No pun intended here. And we have got our code in a library. So if I go back here to my, where's the browser? There it is. If I go back to the overview of what we are planning to do, we can now take an input image that we have here. I'm going to zoom in a bit. We can take an input image. We can split that image into sub images, so that would be part here of that puzzle processor that we have to write. So the code that I just wrote here, the code that takes an input stream, splits it into sub images, all of this is later going to run in the cloud. What we're doing here is we're verifying that everything is working without deploying it to the cloud. So that's always important. If you have got these cloud-based projects, it would be kind of a bummer if for every little change you would have to go ahead and deploy that to Azure. So if you have to do that, that's probably not the best design approach. So try to solve these things locally and build small components like I'm doing it here. So build one thing that solves the puzzle but has no idea about images. Build one thing that splits the image but has no idea about puzzle solving. And that then allows you to, in the end, to bring all these little pieces together and create something that is a lot bigger. So we've got the solver here, we've got a part of the puzzle processor. So what we need next is a way to turn these characters, these images, into text. That means we need to have a look at the custom vision API. So if we look at the plan, how I want to go ahead here with this series. In the first episode, we had a look at the general architecture, what we were planning to do. Then I installed the storage emulator, talked about that. This allows us to store the converted images locally. We had implemented the puzzle solver. Today, we talked about splitting the puzzle image. We now have got separate sub-images, and we are ready to, well, recognize them. So we now can do two things. We could either go ahead and say, well, we're going to skip this part here, the 3.a, and move on to this subpart here where we talk about custom vision API. We could now look at the vision API and upload some of our sub images and see if they are recognized correctly. This could also be something that somebody else is working on. So again, the idea of creating separate components that are independent from each other. Or we could say next time we have a look at the blobs first. So that would then mean, how do we get that image uploaded to somewhere, to the cloud or to our locally emulated cloud? And how do we hand it over to an Azure function that would run the code that we currently have in our little test application? So now that I think about it, I think that's really the next thing we want to do. So just continue on working on that image, move that code, so to say, into the cloud. We could even try and deploy that to Azure then right away. I think that's better than now working again on something completely separate, which would be the custom vision API. So yeah, that's the plan then for next time. We are 1 hour 10 into this. So even if I started now with the blobs or anything else, we would not be able to complete that. So I think I'm gonna stop here for today. That's a good progress that was made here. We've got our image splitting in place, and we can continue on this next week. If you have got any comments, if you have got requests or ideas, make sure that you check out the repository. Leave me an issue there. It's github.com/chrome/word-puzzle-solver. Like I said, you find the completed version there, but you can leave me an issue there and submit ideas for the upcoming sessions if you like to. And then we want to have a look at that. Also, if there are questions, I'm always happy to answer them there. All right, so I'd like to say thanks to everybody who's here today, and I'm gonna see you next week. It will be, I think, next Thursday, again, 9:30 a.m. Central European time, summertime now, when we continue. Thanks for joining, everybody. Have a great day and goodbye.